Alright, welcome back to Physics January 2018, question 3. So it says, define the term energy and state it as a unit. So energy is a capacity for doing work, and it has units of joules. So here we go. Energy has the capacity for doing work, and so we're going to say it has units of joules. Great. So now we're moving on to 3B1. It says, complete table 3 to show the main form of energy associated with each of the following examples. And we have the examples, and we have the energy is empty. So we're going to correspond the form of energy to the example. So radioactive decay is definitely nuclear energy. Radio waves, X-rays, electromagnetic, or you could say light energy. I'll say electromagnetic. It just sounds better. And then objects in motion, well, guess what it is? Definitely kinetic energy. Now it says state the main energy conversions taking place when a flashlight is turned on. Well, the main ones will be from chemical to light. And it's only for 2 marks. So I know you want to put potential, kinetic, blah, blah, blah. But this is the main one. So it's the chemical energy from the battery that gets transformed into the light that we see, which is also energy. Remember, it's photons, so chemical to light. 2 marks. You don't have to waste time writing extra stuff. Alright, so that's done. Now we move into our favorite question, which is the pendulum. And this is a question, or this is something you would have done as one of your first labs, or second or third labs, depending on the teacher you have. And it pretty much deals with gravity, swinging based on gravity or kinetic energy. So let's go. Figure 4 shows a pendulum of mass 0.5 kilograms oscillating in a vacuum, which that means there's no air. X is the lowest position of the pendulum where its maximum speed is 1.8 meters per second. Calculate the maximum kinetic energy of the pendulum. So we know that kinetic energy, which is EK, is equal to a half mv squared, and to make it easier for you, you could say mv squared over 2. And we know that we have V, which is 1.8 meters per second. And we have the mass, which is 0.5 kilograms. We have everything we need. We have this, we have this, and we're looking for this. So EK is equal to 0.5 kilograms times 1.8 meters per second times 1.8 meters per second, because remember the velocity was squared, and all this is over numeral 2. When you calculate that, you want to calculate on top first, put it in brackets and then divide by 2, and look, I have my calculator today. So let's do this. So it's gonna be, see, the phone was better because you could see everything. So you're gonna say 0.5 times 1.8 times 1.8. Let me press enter if you didn't put your bracket, and then you just divide by 2 and you get 0.8 joules. So equal to 0.81 joules. Well, this will give you kilogram meters squared over seconds squared, which is equivalent to a joule. So you could write 1 kg. You don't have to do that, but this is just for general knowledge. Over s squared is equivalent to 1 joule. And that's how you know you're correct. Alright, so it says, use the principle of conservation of energy to find the maximum gravitational potential energy of the pendulum. So at some point, EK will be equal to EP. So therefore, EP will be equal to that, 0.81. Cool? And that's just 2 max. Okay, so finish with that. And it now says, calculate the greatest height h. Alright, so we're going to calculate the greatest height h, and we know that since EP is equal to mgh, right? We can say that, and we know that EP is also equal to 0.81 joules, which is also 0.81 kilogram meter squared per second squared. We could just say 0.81 kg meter squared per second squared is equal to 0.5 kg times 10 meters per second times h. And therefore, if EP over mg is equal to h, then h should be equal to 0.81 kg m squared over s squared divided by 0.5 kilograms times 10 meters per second squared. That goes, that goes, this goes, that goes, these two go, and our units are correct because height is measured in meters, see? And so we would say now, let's say 0.81 divided by 5, but I'm going to put the whole thing in there, times 10, 0.162 meters. And that's my answer. Good luck.